Welcome back to the deep dive. We talk a lot about electric vehicles, clean energy, but have you ever stopped to think what's actually inside those electric motors? The ones powering EVs, robots, all sorts of things.
It's something most people probably don't consider day to day.
Exactly.
Hmm.
And what if I told you that a key component in many of them comes with, well, some pretty significant environmental baggage,
Mm,
and even geopolitical strings attached?
it's a hidden cost, really.
It is. Which brings us to today's topic, something really interesting called Spinrel. It's a new type of electric motor coming out of Italy from a group called Green Silence.
Yes, an Italian industrial hub bringing together a few companies.
Right. And our mission today is to explore these Spinrel motors. They're apparently compact, super quiet, efficient, recyclable, but the real kicker, they're built without using any permanent magnets.
That's the absolute core of the innovation. No magnets.
And the implications are huge for the environment, for supply chains. We'll be digging into it using some great sources. Bits from Motive, articles on Corriere.it, Open.online, eMob, all focused on this Italian tech.
Sounds good. It's a fascinating development.
So to really get why Spinrel is potentially such a big deal, we need to talk about the status quo first.
Hmm.
The problem with today's motors.
Right. Context is key.
Most common synchronous electric motors, the ones you find in a lot of EVs, for instance, they rely heavily on permanent magnets.
Correct. Strong permanent magnets are crucial for the power density we expect in many applications.
But these aren't just fridge magnets, are they? They contain a pretty high percentage of rare earth elements. I read somewhere it could be up to 30%.
That's right. Sometimes even more, depending on the specific design and performance requirements, and rare earths. Well, the name is a bit misleading. They're not that rare in the ground overall. No, the issue is they're difficult and, frankly, dirty to mine and process into the high purity forms needed for magnets and other tech.
Right, I've heard about the environmental impact. It sounds pretty severe. Lots of pollution, toxic waste.
It is. The extraction process often involves harsh chemicals, creates radioactive byproducts in some cases, and uses enormous amounts of water and energy. Think vast contaminated tailings ponds.
Ugh, not exactly green then. And what about disposal?
That's the other end of the problem. Recycling these magnets is complex and often not economically viable. So many end up in landfill, potentially leaching harmful substances. It's a linear take-make-dispose model, really.
So a big environmental footprint. But you also mentioned geopolitical issues.
Absolutely. This is critical. The global supply chain for rare earths is heavily concentrated. China dominates not just mining, holding around 37% of global reserves, but crucially, the processing and refining stages.
So one country basically controls the tap for a key ingredient in green tech.
To a large extent, yes. This creates obvious vulnerabilities, price spikes, export restrictions, geopolitical leverage. It makes manufacturers worldwide very nervous and dependent. It's a strategic bottleneck.
Wow. Okay, so we've got environmental damage, geopolitical risk. Are there performance downsides to these magnet motors too?
There can be. For one, rotors with permanent magnets are generally heavier, which impacts overall vehicle or machine efficiency.
Okay, heavier rotors. What else?
A big one is heat sensitivity. The performance, the efficiency of permanent magnet motors can drop quite significantly when they get hot during operation.
Which they often do in demanding situations, right? Like in a vehicle or industrial machinery.
Exactly. So you might lose efficiency precisely when you need the power most. It's a real limitation.
So, okay, just to recap, standard electric motors often mean polluting mining, geopolitical dependency, heavier weight, and performance drops under heat. That sounds ideal.
It's far from ideal. It's sort of the accepted trade-off, until now, perhaps.
Right. Which brings us back to Spinrel, this Italian answer. Tell us about the Green Silence group behind it.
So this is a collaboration, an industrial cluster, bringing together the know-how of three companies, Motive, Settima Meccanica, and Spin. And it's backed by a private equity fund, Xenon, which suggests serious investment and belief in the technology. They basically looked at all those problems we just discussed and thought, there has to be a better way.
A way without the magnet.
Precisely. They decided to engineer their way out of the problem. The core innovation, unveiled at that expo in Cologne, Germany, is a motor that achieves the necessary magnetic fields without any permanent magnetic materials.
Oh. How do they actually do that? It sounds almost like magic.
Not magic, but very clever engineering. Instead of relying on materials that are intrinsically magnetic, they use the shape of the rotor itself.
The shape.
Yes, they've designed it with these very specific internal cavities, carefully calculated air voids, and solid steel sections. By controlling the path the magnetic flux takes through these structures, they can create the strong, directed magnetic fields needed for rotation. It's function through form, essentially.
Wow. So manipulating the magnetic field using geometry instead of rare earths.
Exactly, it's a fundamental rethink. Alessandro Tassi, Spin CEO, mentioned it took about 3 years of just pure research, followed by 2 years of intense engineering to make it a practical, manufacturable reality.
5 years. That's serious R&D. It shows how challenging, but also potentially rewarding this kind of foundational shift can be.
Absolutely. It's not just tweaking an existing design, it's building from different principles.
Okay, so let's unpack the benefits. What does this magnet-free approach actually deliver, starting with the environment?
Well, the most immediate and obvious win is eliminating the need for rare earth mining and processing. All that pollution, the waste ponds, the energy consumption gone, at least for this component.
That alone is huge.
It is, but there's more. The materials they do use, mainly steel and copper, standard industrial materials, are highly recyclable, so you get this double benefit. Cleaner production and a much easier, more environmentally sound end of life.
A more circular approach.
Exactly. It significantly lowers the motor's overall environmental footprint across its entire life cycle.
Okay, massive environmental plus points. What about performance and efficiency? Does ditching the magnets cause issues there?
Apparently not. The sources suggest Spinrel motors offer higher energy performance and, interestingly, better noise abatement. They're quieter.
Quieter and more efficient. How?
It relates back to the design. By getting rid of heavy magnets, the rotor can be lighter. And crucially, this design is much less susceptible to losing efficiency when it heats up.
Ah, so it addresses that heat-related performance drop we talked about with traditional motors.
Precisely. It offers more consistent, reliable performance under load, which is a major practical advantage in many applications. More robust, really.
So, better for the planet, potentially better performance. What about the geopolitical angle? This feels massive.
It really is. Think about it. If you don't need rare earths, you instantly reduce your dependence on that concentrated, volatile global supply chain, controlled largely by one country.
You sidestep the bottleneck.
Completely. For manufacturers, for entire industries, even for nations, this offers a path to greater strategic independence. Less worry about price shocks, export controls, or using critical components as political leverage.
So building resilience right into the technology itself.
That's a great way to put it. Technological self-sufficiency in a key area. It could genuinely reshape supply dynamics for electric technologies.
Okay, this tech seems incredibly promising. Where are we likely to see it first? What are the immediate applications?
The focus initially seems to be on industrial and commercial vehicles, both on-road and off-road.
Like what specifically?
On the road, think things like last-mile delivery vans, city buses, school buses, refuse trucks, vehicles that operate intensively, often in urban environments.
Makes sense. And off-road.
Agricultural machinery tractors, harvesters, construction equipment like diggers, and things like forklifts in warehouses, again, demanding applications.
And wasn't there a surprising application mentioned?
Ah, yes. Ultra-silent humanoid robots. Which is fascinating, isn't it? It suggests the potential for precision control and low noise is really high.
Silent robots. The future is quiet. Okay, so it's not just for big vehicle propulsion then.
No, the technology seems quite scalable. The sources mention it can be adapted for smaller components within a vehicle, too.
Like,
Things like electric motors for windshield wipers, power steering systems, braking assists, even power windows. Components we often take for granted but still rely on small electric motors.
imagine a whole vehicle where every motor, big or small, is magnet-free and highly recyclable.
That seems to be the vision, and they're looking beyond vehicles, too.
Oh, where else?
The next step mentioned is adapting it for industrial uses like pumps, fans, hydraulic power packs. Basically, many other machines that need efficient, controllable electric motors, especially those sensitive to speed or running continuously.
Wow, the potential reach is enormous then. It's not just an EV thing. It could impact manufacturing, infrastructure.
Exactly. It's a foundational technology shift. If it delivers on its promise, it could improve efficiency and sustainability across a whole swath of industries that rely on electric motors.
It really feels like we've dug into something quite profound today. These Spinrel motors. They're a testament to innovation, tackling environmental problems, geopolitical risks, and boosting performance, all by fundamentally rethinking the motor's design without magnets.
It's a prime example of how addressing a core material dependency can unlock multiple benefits simultaneously.
It really is a big step towards a more sustainable and perhaps more independent electric future. So here's something for you, our listener, to chew on. Consider how changing one seemingly basic component, like an electric motor, could send ripples through entire global systems. What other hidden dependencies might exist in the technologies we rely on every day, just waiting for a similar revolutionary redesign? And what could that unlock? This has been an absolute fascinating deep dive, and we really hope you've enjoyed getting up to speed on this game-changing tech with us. If you want to keep exploring incredible innovations like this and, well, not miss out on future deep dives, please make sure to follow our channel wherever you get your podcasts. I honestly can't wait to share more with you.